Hello students, welcome back. In this video we are going to conclude chapter 9 by going through chapter 9 section 4. Now we are doing two samples and then we are analyzing and making inferences about two variances or standard deviations. So in this section we present the F-test. We have not done the F-test. And that is a different type of distribution. So the F-test requires that both populations have normal distributions, and that is a pretty strict requirement that both samples have normal distributions. So our objective here is we are going to conduct a hypothesis test about a claim about two population variances or standard deviations. So some notations, we say S of 1 squared is the larger of the two sample variances. So whichever standard deviation or variance is larger is going to be your S1. So if you have two samples, you can't just arbitrarily assign one as sample 1 as one as sample 2. Whichever has the larger variance or standard deviation is going to be your 1. Whichever has the smaller is going to be your 2. And then the subscripts to follow. So the requirements are that they are independent, that it's good data, simple and random, and that the populations for both are normally distributed. So your test statistic for the F distribution is going to be F is equal to S1 squared divided by S2 squared. And since S1 is going to be the larger of the two sample variances, F is always going to be a positive value greater than 0. Actually, you can say it's going to be greater than 1 because the if this is going to be greater than that, then it won't be between 0 and 1. So let me scratch my last statement. It will always be greater than 1. I'm actually going to make a homework question on that because I think that's a good analysis that you should be able to make. So p-values are automatically generated by technology, or you can use table A5. A5 is found on page 688 to find the range for the p-values. Critical values are similar concept. You can find it by using table A5 and then using the significance level with the number of degrees of freedom being n1 minus 1. Notice we're using n1 here. And that represents the numerator. The denominator is going to be n2 minus 1. So when you're using table A5, you'll find that on the left-hand side, it's going to ask you for the numerator, and on the top, it's going to ask you for the denominator, and then you kind of play Battleship where you find the value where the two intersect. So find the critical value. Because we are stipulating that the larger sample variance is the S1, all one-tailed tests will be right-tailed, and all two-tailed tests will require that we only find the critical value located to the right. This is important because you're going to get a question and you're going to be like, well, how do I find the left-tailed one? You don't have to. So you only need to find the critical value located to the right. We have no need to find the critical value at the left. So your F distribution is given by this formula again right here. And we are assuming, the null hypothesis would be that we are assuming that the populations have an equal variance. That is sigma 1 squared equals sigma 2 squared. So similar to the chi-square distribution, the F distribution is not symmetric. The values of the F cannot be negative, and then the shape depends on the 2 degrees of freedom. So if the populations have equal variances, then the ratio will be 1, or tend to be close to 1. And since we are stipulating that S1 is larger, then a large value for F would insinuate that they are further apart, and S1 is much more significant. So let's go to this example right here. And we'll use the same example we did in section 9.2, where we test the claim that the two samples are from populations with the same mean. That was what we did in 9.2. Now we will use the same data with a 0.05 significance level to test the claim that the course evaluation scores of male and female professors have the same variation. So different than the mean. Now we want to know its variation. So first you have to do your requirement check. The requirements are satisfied, you would have to plot them on some kind of graph to see that it's normally distributed, but we're just going to proceed. So for females, we get our standard deviation of 0.563, and for males, we get S is equal to 0.395, and we can conduct the test either using the variances or standard deviations. And because we stipulate that the larger variance is going to be S1, we will let the females be the sample 1, and then the males will be sample 2. Again, these values could be determined from your TI-84 or StatCrunch, Excel, anything. So your original claim is going to be that the variances and standard deviations are equal. And since that involves equality, that will be your null hypothesis. So then the original claim is false, then they would not be equal to each other, and we will let that be our alternative hypothesis. Significance level was given at alpha equals 0.05, and because we are dealing with two population variances, this is an F distribution. So the test statistic becomes F equals 2.0269. So, for a two-tailed test with a significance level of alpha, the area of 0.025 is in the right tail. The numerator, the degrees of freedom, is n1 minus 1 is 11, and the denominator is n2 minus 1, which equals 14. So you kind of have to play Battleship with table A5, and you find that the critical value of F is between 3.1469 and 3.0502. So the test statistic is less than the critical value, so the area to the right of the test statistic is greater than 0.025. And for this two-tailed test, the p-value is greater than 0.05. So for the critical value, you find that the critical value is between 3.1469 and 3.0502. And the test statistic of 2.0269 is less than the critical value. So here is your test statistic. Here is your upper critical value. We are not interested in finding a lower one. So the test statistic does not fall in the critical region. So the test statistic of F equals 2.0269 does not fall within the critical region, so we fail to reject the null hypothesis. So there is not sufficient evidence to warrant rejection of the claim of equal standard deviations. I'm not done yet. I do want to show you how we can do this using StatCrunch. So I'm just gonna kind of split screen this for a minute. So I went to StatCrunch, which again, you can get StatCrunch by going to any homework, go to question help, and then open up StatCrunch. You should know that by now, but if you don't, I'll give you a chance to learn without having to embarrass yourself. We then could just give the computer the summary of these values, or we can just type it in. To save time, I did this ahead of time. So here are your 12 female data points for variable 1. Here's your 15 data points for variable 2, which is male. Now we're going to go to stat. We're going to go to variance stat. We are dealing with two samples, so we're going to go here. Then with data or with summary. If we wanted to do with summary, we would have to know what the variance and the sample size is for each of the two samples. Since we don't know that yet, technically, for the sake of how I typed it in, we are going to do this with our so we have our sample 1 is going to be variable 1. Our sample 2 is going to be variable 2. We are going to perform a hypothesis test, with that going to be compared to 0, compute, and here is your value right here. Notice that it is going to be the same F value as well. You can also solve this using your TI-84. There is a function right here. If you go to, I had it up already, stat, go over to tests, and then go down to your FE, which is to sample F test, hit enter, and then if you have your data, you can pull up the respective lists, or if you have your summary or your stats, you can type that in as well. And that concludes Chapter 9. Any questions, please email me. Thank you.